Hello everybody and welcome to today's introduction and overview session in the certificate program in Python for algorithmic trading. My name is Yves, I'm founder and managing partner of the Python Quant, and I will be your guide today and mostly through the entire program. I've prepared quite a slide deck which will help us navigating the different topics. And I will immediately start with introducing the agenda and the single points. And as we go, we will see many different areas of the program. We will encounter a couple of case studies. I will provide you with a few demos. I will guide you through the Quant Platform, for example, in this context. But I will have a little bit more in terms of general context for our whole program as well. So it's all about setting the stage, showing you a little bit what to expect. And towards the end, we will then discuss what a good study plan might be, so that you have a little bit of guidance, because the material and the content provided as of today on the Quant platform is indeed rather comprehensive. Well more than 100 hours of video material and so forth, close to 1,000 pages to read. So it's quite a bit. Not everything is equally important, but I will try to emphasize what the red line is and where to focus on. In the meantime, when you have questions, you can use the Q&A section in the GoToWebinar panel and can formulate your questions there when time allows, or when I think it makes sense. I will get back to the questions and we'll answer them. Well, let me jump already here into my slide deck. And the agenda for today is as follows. After a quick introduction about our company, myself, and what we've been doing recently, I will give an overview of the program. It's not that detailed, but it's rather intended to give you a high-level overview in this regard. We go into a few more details in the part case studies and demos, where I have picked out a couple of interesting topics that I want to illustrate technically. So I will do a couple of live demos, set up, for example, a little droplet cloud instance, for example, or do some interactive analytics based on Jupyter Notebooks. Then in terms of what we're up for, namely algorithmic trading, I want to set the stage theoretically with regard to random walks. This is just a brief part here, but I think it's the benchmark against which we have to fight, in a sense of that if markets would behave according to random walks, there wouldn't be any benefit in analyzing data that is available to everybody else. But nevertheless, we will try our best, because we these days have more sophisticated analysis technologies available, both in terms of software and algorithms, as well as in terms of hardware that we can make use of, compared, for example, to a couple of years ago. I will then move on towards a very current topic, which is called technological singularity, a point in time from which on we will have something that is called human level intelligence, or even superhuman level intelligence. I will illustrate how this might happen on the basis of the chess example. I think everybody can relate to this. Even if you're not playing chess, you for sure have heard of it and what has happened there in the past, a couple of years ago. So we will revisit this example based on a very current book by a former world champion, Garry Kasparov, to move then on towards what is called a financial singularity. The idea that from some point in time, machines will take over more or less all investment and trading decisions. Then a quick view at what people have to say about the beneficial combination of man and machine. In point number 9 here, I will show you a few things with regard to the style of the complete program and what to expect. And last but not least, as already mentioned, the study plan, which is more or less kind of a guideline. I know many people are kind of working full-time and might not be able during every week to study what is on the plan. So we typically don't set any hard deadlines in this regard. And once again, it's kind of a guideline, what we call here the study plan. Let me start with a quick introduction about the Python Quant group. You see our overview with the major topics that we are concerned with these days. At the core, indeed, is training here about Python for finance and algorithmic trading. But we also provide services to financial institutions on a global level. We organize events. Some of them are coming up towards the end of the year. We provide the certification, which you are part of here. I personally have written 3 books about the topic. We have open sourced financial analytics library, and we run the Quant Platform, which we will see today in action as well, where we have well beyond 10,000 registered users. So if you're interested, a little bit more background about our company, just visit tpq.io, and there you'll find a wealth of further resources in this regard. The Quant Platform itself covers quite a number of important areas when it gets to data science or financial analytics in particular. So in principle, what this graphic shall illustrate here is kind of like a journey where you start with an idea, and you have maybe towards the end an application in mind. You start with maybe interactive financial analytics, you get maybe a little bit of training, you do visualization, you implement certain analysis features based on proprietary or open data sources, so you can use your own data sources or what is out there in the public domain, up until the point where you can publish maybe something static, like should be a notebook, more like in a research context maybe, or also it's a full-fledged deployment environment, which means you can also deploy, for example, web-based applications, for example, using the Flask web framework, to name just one example. So it's, I would say, yeah, a good environment which provides you with a single, very quick registration in the browser with all the nice tools that our ecosystem in Python and open data science provides us with. And it's really nice and efficient to use from usually almost any machine. If you're interested what I've been doing, what I'm up for, if you're interested in my talks, this is an area which you won't find in a comprehensive manner on our company website, but on hilpisch.com it's more like a history of all my talks, well beyond 100 talks with videos, further resources like GitHub repos, gists, and many, many more. It's not about my private biography there. It's really about Python for finance. When we started giving talks and doing what we do these days many years ago. So this is one area where you get more or less informed about the history. I think this is a good point to bring you to my Twitter account if you are interested in. So my Twitter handle is dygh, and when I go to my profile here, it's also, I am not tweeting here private stuff. I'm just tweeting here either stuff that relates to a company or that is related to Python, or recently more artificial intelligence things, but also some things with regard to productivity, which is one of my hobbies, so to say, and all things related work and being efficient and being effective in this new world. You see here, for example, building a blockchain in Python, one of my recent tweets, a very interesting post here that I discovered. So I usually share that stuff. And you also see here kind of information about what is up. So when there is an upcoming talk or something else in terms of events, I usually tweet about it. Even if you're not able to attend, I usually tweet also the resources like the slide deck or kind of the GitHub repo or gist or whatever I'm sharing. So even if you are not there and can listen personally, you at least get access usually a little bit earlier than on my private page to the resources. So dygh is my Twitter handle, but a simple Google search, Twitter and Yves Hilpisch will lead you the correct way. My 3 books that I've written, I think the most popular one is the one in the middle because it's the most general one. I just recently signed a contract with regard to the 2nd edition, which will be due mid-2018. There are many things that are worth updating. So in print, it appeared at the end in December of 2014. So it's been a while, but it's still kind of used by many people around the world. But there are a couple of issues that we will cover later on as well. For example, the the go-to data, open data source that has been used by many, not only by me, but many others as well, like Yahoo, in combination with Pandas data reader, doesn't work anymore. And all these things are worth updating because they simply are not working anymore. So it's a little bit annoying. On the website itself, so if you have the book and are interested in up-to-date codes, there is a GitHub repository attached to it where I, let's say regularly, not on a monthly basis, maybe on a quarterly or half-yearly basis, I update the code for Python for Finance, so that at least the Jupyter notebooks and that come with the book are still executable. I just did it recently, but I think now there is another change with regard to the Google data source, which needs to be accommodated, which is rather new once again. So things are moving in the space, and therefore the need to update stuff regularly. The other two books are, I think, really specialized. So if you're not working in the derivative space nor in the volatility and variance area, then these books might not be of much interest. But for people working there and using Python, I think they are kind of a perfect fit. We are here in the middle of our certificate program overview, and this is a program that we have come up with at the beginning of the year. So it's a second round, and I think, like usual, people participating in a second round benefit from what we have been doing before and from new additions, from updates and so forth. So we try to do our best and add new stuff and add new twists, cover new topics, and also based on feedback that we have been provided with, to give you timely and the best experience that you can get in this regard. At the core is our PyAlgo course, so which is called Python for Algorithmic Trading as well. So we differentiate between courses, classes, and programs. So this is the basis for a few things, and it's also at the core of what we do. It's currently well beyond 450 pages as PDF, but my preferred version is for sure the online one, because you can navigate much more easily. It's a nicer rendering, and you find it on the platform. I will show this later on, but this is really at the core of what we do and provides also topic-wise a little bit of a guideline. You would see when you have a look at the study plan and compare this to the course material here, that the study plan is along the lines of this material here, of this table of contents, of which you see just a part on the left-hand side. And in the other columns of the study plan, you then see additional optional material, auxiliary material that is useful for the different areas, or that you should master as well once you reach the end of the program. Then we're also proud that a couple of publications are recognizing what we have been doing. So when we started more than 10 years ago with Python for Finance, people said, well, you are kind of a little bit of insane, because Python in the financial world, where everything or almost everything is computationally demanding, Python cannot really be used. It's not useful because it's so slow, it's so here and there. And I'm so happy that now we are in a time where the biggest banks in the world, where the biggest hedge funds in the world, almost all rely on Python as a core technology, not kind of like a side story or a little piece here, a little piece there. No, many big banks like Bank of America or JP Morgan, they run their core systems based on Python. Big hedge funds traditionally have been the first ones to make use of it, and so others recognize what we have been doing there as well, from the financial as well as the technology side. So we're really happy in this regard that a few take notice of what we have been doing there over the years. With our partners, many things that we do, many amazing things that we can provide our community with wouldn't be possible. So, for example, we cooperate with Thomson Reuters, a big data provider company, particularly with the London office since years, to organize our Python for Quant Finance meetup there. We currently have more than 2,200 people in our group. Typical meetups have up to 100 people in attendance. We try to get external speakers. Usually we have at least 2 talks per night, and we have kind of like 4 to 6 meetups there, the bigger ones per year. And thanks to Thomson Reuters, who sponsor these events, we are able to provide the community with such free events. With Fitch Learning, we organize NCQF Institute. We organize a couple of events together. So in London, upcoming, again, is for Python Quants Bootcamp series, but also algo trading workshops in the context of the Quant Insights conference. Once again, with the bigger companies, they can provide the infrastructure. We are mostly then involved with regard to providing content and leading the seminars there, so to say. So I'm really grateful that we have such strong partners. Also, to mention here, HTWSR, which is a local university in Germany, with which we cooperate to be able to issue a university certificate, which is even good for 5 ECTS points in Europe, so European Credit Transfer System. If you study for a master program, for example, you can even use our certificate points in the context of such a master degree. After this quick introduction of what we have been doing, what it's all about at the Python Quants, and in my personal life, I must say, because I'm living this 24/7, so to say, we come to the overview of the program. What we are going to do in the program has to be seen against a few important megatrends. Maybe there are more, or maybe you say, well, this and that is also happening. But I think with regard to what we are up for, Python for algorithmic trading, we benefit and capitalize on 4 main trends there. Mostly in terms of our online training program here with regard to the first 3 columns, but I think with all what we do here at the Python Quants, and you have learned about it before, it's also the 4th one. But let me start with the first column, software, and the first row there. So open source, of course, is revolutionizing. Just to mention GitHub and Python as 2 examples. And just recently, in historic terms, TensorFlow as the deep learning library, open source by Google. We have really fantastic means there these days. It's not just that we have stuff here in terms of, yeah, we have something. No, on the second level, when I get to the second row here, we have cutting edge open source software. So this is kind of fantastic, because we are coming from a world where there have been these monolithic applications, or where you bought kind of a CD, you installed something, and a couple of people out there maybe spend their weekends and re-implemented parts of the functionality of such software or whatnot. So we've come a long way, but now it's kind of the open source world in many, many areas that sets the benchmark. And this is kind of fantastic. So for what we are up for, when we talk about machine learning and deep learning, we can make use of what Google is using for the self-driving cars. So we can make use of TensorFlow there. Then hardware. It's so simple these days, even for an individual, even for a student with absolutely limited budgets, to fire up professional hardware in the sense of open infrastructure. So speaking of the cloud, professional Linux servers that are available, easily scalable, only built by the hour, fantastic. So we will make use, and I will illustrate this quickly based on DigitalOcean, what we prefer, because it's so simple. But of course, this can be done, and the question arises usually, can I also work with AWS, for example, from Amazon or other providers? For sure, but this is a cloud provider where we have made very good experiences, simple, seamless, straightforward. So we have learned to love DigitalOcean in this regard. Then again, getting here to the second row, it's not just any infrastructure like commodity Linux servers that you get access to. Now, here we see a similar trend to the software world with regard to coming from open source to cutting edge software, that you also get access here to specialized hardware. So this is an initiative, I will have a slide for it, where Google recently announced their cloud offering for AI. You see here google.ai, which is targeted towards the use of TensorFlow in the context of deep learning. And the hardware that is provided is specialized in a sense that is specifically designed to be as fast as possible in making use of TensorFlow. So this is what they use is called TPUs, tensor processing units, and this shall suggest that this is really fast at doing tensor-based operations there. On the data side, also open data. My favorite and running story here in this regard is back then when I was at the university, I needed to pay quite a bit of money to get on a little disk a very small, even tiny data set from my professor to do a little bit of analysis within an Excel spreadsheet and to do kind of very simple visualizations of two stock time series from two different stocks there to compare them and so forth. But I have come up with, I needed to come up with kind of cash in my hands, otherwise the professor wouldn't have provided, because the professor also needed to pay for the data set. So this is the history, and now we have in many instances fantastic open data that we can at least get started with. Depending on what you are targeting for in the realm of algorithmic trading, this might not be enough, but for a student, for an academic, for somebody starting to learn the trade, we have fantastic open data sources that we can rely on, at least towards the beginning. And later on, when we know what we are up for, when we can exactly scope out what we want to do, we might move on towards professional data sources, like from Thomson Reuters Icon. Here in combination with the recently launched API and Python wrapper. So from that point on, you have then access via Python to a huge lake of data, and not only historical structured data, but also upcoming soon to streaming data, also to unstructured data in terms of news feeds and other text-based databases. So it's getting better and better in this regard, but we must be aware that kind of like both with regard to hardware as well as with regard to professional data sources, there still is a budget involved. So I'm not aware of any source or resources that are comparable to those two, for example, that are available for free. Maybe, for example, there are academic sponsorships and so forth, or in the context of startup companies, sometimes you find this. But I would say for regular scenarios, these are regularly subscription-based. Same holds true probably here in the area of social mega trends. So speaking of open networks, Meetup, I think, is what sets the stage here. I was talking about the Meetup group I've founded, and I'm co-running these days, co-organizing with two colleagues from Thomson Reuters in London, 2,200 people, all organized via the Meetup platform in the virtual space. But of course, we regularly come together physically. And this holds true also for the specialized events. I see this here similar to what we have in the other areas. It all started with kind of general meetups, and you came together and you talked about Python, and there was a finance guy, there was a bioinformatics guy, and many other people using Python. But these days you have specialized events in the space where it's about Python for finance, Python for quant finance, Python for algorithmic trading, and so forth. It's getting more and more specialized. And in cooperation with the CQF Institute, we are involved in a couple of these specialized events, but there are many others as well. Just to mention Quantopian, not only the platform, not only the community, they're also organizing their QuantCon conference, they're organizing their specialized or focused, let's say, meetup events around the world. So it's really fantastic kind of the resources that we have these days available here in this space. So having elaborated a little bit longer on the mega trends, we might now move on towards a little bit of more of a technical topic. So many things in our world are driven these days by recent advances with regard to machine and deep learning. So speaking of self-driving cars, I don't think that there is any kind of new startup or recently founded startup that doesn't make in any instance use of machine and deep learning. So I think this has become kind of like the core, even though the core at least a very important element of many business models founded these days. So my running example here to compare it to what we do in the financial area is the self-driving car. And if you have a look at the similarities, I think it's striking. So when you say, well, both machine and deep learning as well as algorithmic trading both need data, algorithms, and hardware. So without these, nothing can be really done. Then you have the middle step where you say, well, once we have data, algorithms, hardware, then the work begins, if you like. You do some kind of optimization, training, learning, maybe a couple of other tasks here. Then you do a testing and you validate what you've learned, trained, and learned, or optimized, trained, and learned. To then, in the machine and deep learning space, for example, build a self-driving car. So here it's all about prediction. Should I drive to the left, to the right? What does the car in front of me do? Or even the car one further to the front? Or what is the rear car? And all these things, very, very important and a very ambitious endeavor. So you need lots of data, you need sophisticated algorithms, you need modern hardware in order to get all this together up and running. And for us, it's more or less the same result. It's about, in the end, automation. The car should be self-driving. And our algorithms here in the algorithmic trading area, they should be self-trading. So I use here the expression money-making machine. So this should drive around. This should carry either goods or people that get carried around from A to B. And here, this should start with an initial capital, and it should come up after a while with more capital than it started with. So the two worlds, and you see, are not too different. So I'm pretty sure that we will see more amazing things out of this world coming that will prove useful for our world here as well. Because more or less, with many things that are kind of built here from the machine and deep learning world, we can translate them one-to-one to the problems in our area. Sometimes we can even say that our problems are more simple, or the modeling is not that involved. Sometimes we must say, well, the physical world might be governed by physical laws. People are still debating whether the financial world is governed by any kind of law. So this is still to be decided. Maybe with new data, so for example, alternative data, more granular data, more sophisticated algorithms, better and faster hardware, we will be able to discover things that haven't been discovered before. So this is, from my point of view, a really fascinating parallel universe, if you like, because we can make direct use of what is done here in the upper part, and we can translate it to our algorithmic trading area. More on this in later slides. With regards to the program, now having this background, we have four major pillars or topic areas, if you like. First of all, it's about Python. So the name is Python for algorithmic trading. And the emphasis, I would say, is more on Python than on algorithmic trading. So this is a technology course, not really a proper, pure trading course in that sense. But on this side, I think we cover quite a bit. It's rather comprehensive in this regard. So Python, the tools that you can use like IPython, Jupyter, there are many, many more, but we focus on some. And I think for good reason, but others might have other reasons to use other tools. So this is an ongoing debate on Docker containers, for example, cloud instances, basic idioms in this world, controls for the linear algebra, basic, so the very basics. So mostly what you see here, what you read here, apart from the cloud topic, can be done on a local machine. So this is all kind of proper basic. Later on, if you want to scale, maybe you might reach the limits of your local machine. But we will see that scaling and going to the cloud with what we are doing there is kind of straightforward. Then, of course, we have the part where we do financial data science, where we analyze historical financial data, where we use machine learning for classification, where we apply deep learning approaches like deep neural networks, where we do prediction and do backtesting. So this is kind of, if you like, the intelligent core, so to say. Basic tools, the intelligent core. And once we have verified and validated our idea and say, well, this looks promising, let's test it, in the real world, maybe first with paper money, then later on with real money. We then need to move on to the real world. And the real world means that on a constant basis, in real time, we are retrieving data, and depending on what we do, this might be quite a bit of data that we need to digest in real time. We might want to visualize the data. We need to implement online algorithms. They are a little bit different than what we would see, for example, in the context of vectorized backtesting. We need to implement a real-time communication. So placing orders doesn't make sense if I get a signal this afternoon at 2 p.m. 05 and I just have, so to say, the opportunity to place an order 3 hours later. This won't work. So we need to be able to communicate in real time with the platforms. So beyond data digestion and data crunching, we also need to communicate that way, namely online in real time. And we need to master the APIs of the different platforms that we might want to use. So basically, we cover here in the course and the material so far 3 platforms over the next 3 months, which means over the course of the certificate program. We will add a 4th one. More on this later on, but we are working hard with the respective provider to offer you another highly valuable proposition there. But again, more on this a little bit later, but be assured we will introduce the 4th one over the course of this program. And last but not least, it's all about doing it yourself, because it's, I like to compare this like not watching a soccer game on a Saturday afternoon, which is kind of a favorite hobby of most Germans. I do it sometimes myself, like last Saturday, watching the German Bundesliga teams competing against each other. It's rather like going on the field and training soccer for yourself, to be able to do it yourself. And this do it yourself is really important, because sometimes I recognize that people have this consumer mentality, which is not a bad thing for many, many things. But I think what we are striving for here is not that you have seen everything that is possible, but that given your goals that you follow with the program, with participating in the program, you will be able to reach your goals, to implement your trading strategies, to get it up and running, to be successful later. Maybe this might also mean to land your dream job with a big financial institution. But no matter what, this is kind of the benchmark, and this means that you need to be able to do it yourself. Therefore, own strategies and backtesting programs, own trading code. We will have a 1-day and a 1-week trading competition, smaller ones. Here it's not about the P&L itself. So here it says P&L, but it's more about checking whether you are able to put all the pieces together. This is the basic thing. And we have done this now for the first time recently, and exactly what we wanted to achieve with this experience was proven true. So many people say, well, I noticed I have shortcomings here. I noticed here I didn't understand this little piece. But in the end, this experience helped me in putting all the things together, reviewing what I was missing and so forth, to then be able in the end to implement a proper research project, which is the major basis for the certificate. So these are the 4 major pillars and topic areas with regard to the program. This is now translated into these 4 columns. So where we have the foundations, where we have data science, where we have algo trading and experience. So this is, so to say, a transpose of the topics. Where you see a red dot here, we will illustrate, I will have case studies that touch upon this slightly. So we don't go into that much detail here because time doesn't allow, but this is just to show you a few things here with regard to what you can expect in the program. You see, it's not from every area, but I think we have a good kind of cross-section of the topics that we touch upon here, so that you get a good feel of what you can expect. On the left-hand side, the foundations, you see that there are 4, like throughout, 4 different boxes. First is introduction to the Quant Platform. I will do this later on. There are also multiple other resources that you can rely on in this regard. Then we have Python environment and infrastructure. Alone for this topic, you find a few hours, like 5-6 videos with close to 10 hours of material that cover this topic on the Quant platform. Then we have the basic finance in complete economies and basic finance in incomplete economies. So this is for those who want a refresher with regard to some financial topics, and for those who want to get kind of a gentle introduction to Python applied to financial problems. So the topics covered there are really kind of basic, and in particular the data structures and the examples are very, very low level and introductory, and this with purpose, so that it's not kind of the issue, do we have here 100,000 elements in the vector? No, it's usually kind of 2 elements in the vector, 3 elements in the vector, so that you can, if you like, that you can replicate all the results that are elaborated on there with pen and paper for yourself. So this is kind of the level that you can expect here, but in the material itself, there are also a few advanced examples and case studies included, but mostly, again, it's based on very simple introductory examples. Then we have the core packages in data science like NumPy, Pandas, Matplotlib. They simply need to be mastered in order to be able, for example, to move on to financial time series management, to more sophisticated things like stochastics and statistics, and maybe special and advanced topics, symbolic mathematics. You might say, well, this is not interesting for me. I'd rather want to focus on the other topics. That is fine. So in the study plan, for example, you will see that this is optional, these topics. So you can add to this if you say, well, this is important for me, but you don't have to. So there is kind of a little bit of a room for individualization, if you like, of the program. Then on the algo trading side, of course, nothing works there without financial data. So one major block here is financial data backtesting and prediction. This is a huge block. So this block alone might be worth 3 other blocks here in the overview. So because it's so important, because it's at the core of what is done there. Then we have streaming data visualization, which is also important and one of my favorite ones, because you see nice real-time visualization. So things are happening in real time and you can adjust them and so forth. So it's a nice topic. Of course, the online trading platforms are as important as here at the background, because without having a trading venue, an execution platform, there is no algorithmic trading. It's more like algorithmic analysis maybe, but not algorithmic trading. So the online trading platforms, of course, very important and also one of the core topics here. We are constantly improving the wrapper classes that we work on here. We are even working on a package in this regard. So my hope is that over the course of the program, we will have a dedicated session where we can show the updated new versions, which will hopefully make it even more simple. So as we move on, so to say, and as other elements of the program move on, we try to improve on the wrapper classes here as well. But I think the wrapper classes as they stand right now, for example, for Wonder, which I would showcase in a few minutes during this overview, are already kind of really useful and make working with the platforms what we call really Pythonic and convenient. Then the automation of algorithmic trading operations, also important. So here you do the backtesting, you learn how to digest and work with streaming data. Then you learn how the API of the platform work. But in the end, if we talk about algorithmic trading, what we typically mean is automated algorithmic trading. So recall my little comparison slide between machine and deep learning and algorithmic trading. The ultimate goal is to have automation implemented, be it in the form of a self-driving car or of our money-making machine. So therefore, automation also a separate important topic. The experience part, it's here the out-of-sample backtesting competition that we do in between, and towards the end, a single day live trading competition. This is just for you to get up and running and to see if you have all the pieces together. And then a 1 week live trading competition. And last but not least, the important project delivered as a Jupyter notebook. Oh, here you see it's kind of the spell checker that replaced the Y from Jupyter by an I for the planet name, but this, of course, should read Jupiter with a Y. And yeah, these are the 16 major building blocks. And there is, well, a little bit more when we will walk through the platform. I will show you what is there. Not every detail, but at least a high-level overview so that you get a feeling of what resources you have access to. When we talk about the core on the platform, I've tried to bring this to a little bit of a number-based game here. You see 1,000+ pages of Python for finance and algorithmic trading, 40+ Jupyter notebooks, 5,000 lines of code, 100+ hours of pre-recorded video instruction, 20+ hours of additional live recorded session, and we will add more and more as we go. So, for example, one of the most recent addition is a quick talk that I've given at the meetup in London about performance Python. So it's a 45-minute talk about important aspects, how to speed up algorithmic code with Python and the tools like Number and Thyson and basic Python idioms. So the basics here are also important. And in particular, over the next few weeks, I will give lots of talks and workshops, and whenever appropriate, I will record them and will put them up there as well. So beyond the core resources that you have access to, we will also add additional resources which focus then on selected topics and which might be really useful if you are kind of concerned with the particular topic for what you're after. So I think it's quite a bit, and I know that people are always asking, how many resources do we get? What is this and here? And can I get more? Can I get access here and there? And in the end, the experience is that there is more material that most people can digest, in particular in the time frame that we have originally thought of. But again, there is no hard time limit. It's rather kind of like, it is quite a bit that we cover here, so be prepared. It's a lot to learn, and many people say, well, it's amazing how many things there are covered in the program. This is an overview slide that I will use throughout because this is the form of a pyramid and in terms of different layers, illustrating what are kind of the 7 most important areas that we are covering here. So it starts with the infrastructure. Then, of course, we need financial data. And maybe 2 words on the infrastructure. When I talk about infrastructure, what I mean typically is a cloud instance that you set up for very small money. We even provide you with a bonus if you want to work with DigitalOcean of $10. This is already 2 full months for the smallest cloud instance there. But this also involves kind of the Python install. This involves a Jupyter notebook install, which you can then use to access the infrastructure via the browser. I will illustrate this via a live example. And on top of that, you then start working with financial data. Financial data, the basis for everything, in particular for strategy. When I say, well, for example, we are now going and implement an SMA-based strategy, simple moving average, or momentum-based one, for example. This needs to be back-tested, implemented on some data. And so this is the basis for everything to follow. Based on the strategy code, you can then move on and do the backtesting. We cover basically 2 approaches, for which we don't make use in the program of any available library. We focus rather on building the backtesting code on our own, which means vectorized backtesting on the one hand, which is rather efficient, but from a certain point of view also a bit limited, and event-based backtesting, which moves us a little bit closer towards reality in that the incremental data arrival is simulated step by step. And on top of that, we can then move on and say, well, now let us deal with connecting code, which means we should be able to digest data in real time, to do something with the data in real time, for example, simple operations like resampling, but also a regular updating of our strategy and the signals that it generates based on incoming data. And last but not least, also the trading code here in this context. So once we get a signal, we should place an order. Otherwise, no trading, no automation, no money making takes place in that regard. And on top of all that is automation, where we cover topics like money management, capital management strategies, but mostly technical stuff where we say, well, we need to be able to monitor what is going on in real time, maybe some exception handling, and all these things in terms of infrastructure, automation, monitoring, risk management, and so forth are covered in this part. Closing the circle also to the infrastructure, because the infrastructure there will be highlighted and covered once again. But be assured you will see this this slide a couple of times, because it's one of the central ones I use to structure what we are doing and to illustrate in which part we are currently in terms of the contents of the respective session. You will see this in the other recorded videos as well. So this brings me already to the case studies and the demos after the introduction and the overview. They are all kind of designed to be kind of short, but nevertheless insightful in what to expect. I have prepared basically 6 little case studies and demos. The first is that I want to guide you quickly through the Quant platform. There's also one video available to which you should have access. And then we will set up our own Python environment. So maybe, or from experience, I can tell that most people typically in our class and our programs haven't had any exposure, any experience with regard to setting up cloud environments. So I will show that this is all but rocket science, in particular with the scripts that we provide you with. So this is a quick example, quick in terms of what I will be doing. In the back end, it will run for maybe a few minutes, but we don't need to follow along. Then a very simple example, basic finance with Python. Then Icon and Plotly, which is a nice combination. This is, so to say, the only area where I showcase a paid service. So Icon is only available via a paid running subscription. But I think it's really interesting to have an idea of what is possible these days and how powerful the ecosystem has become, in particular when you combine our ecosystem with a professional data source. Maybe not for now, interesting for everybody, but later on when things getting professionalized or grow, or when you say, well, now I'm working with a professional institution, they have Icon, then this is kind of a typical context where I say, well, I'm working here with a professional data source and using the ecosystem that we have. Then streaming data and visualization, very short example, just to show a little bit of code and also show that this is not really rocket science. With not that many lines of code, we are able to digest streaming data and to visualize it. And last but not least, I will show here a few applications of our little Python wrapper in the context of the Yuanda trading platform. You see here, you might have wondered why there are so many tabs open, but basically the tabs are kind of related to different points here. So the one tab that is related to the first point is my Quant Platform account. I think I have a couple of things open here, which I might close first so that I can start from scratch, so to say. So everybody who is taking part in this program has access to the PyAlgo Quant Platform account. This might look a little bit different in every single account. On the left-hand side, you see my home folder. You see here home, but this is my personal home folder. So once again, this might look different. I have here my algo search stuff. There's something new, maybe even, yeah, when I updated this Algo Live now. There is FinPy, which is finance with Python, a couple of other things. Don't be irritated if this looks different to what you have. What you should have in any case, these are the PyAlgo folders and the FinPy folders. These are the two folders containing the materials from the courses. But before I go to that part, let me quickly show you what is there as well. So before I open them, under Tools, you have a File Manager, which allows you to implement typical file-related operations. Then a Task Manager, which allows you to close, for example, Jupyter Notebooks. They're still running. You have an editor available, a web-based one. You can open a new shell, a terminal. there is user forum, and then there are 2 points that you might not see because this is just for me as an admin here. Then there's also my account, which you should have, and administration, once again, is just for the administrator here. Under my trainings, this is the basic content section. So tools, I would say, is, yeah, as the name says, the tools section, and my trainings is the content section. So when I open and I start with that one and go later back to the tools, when I open Finance with Python, here you see that the tab opens and that you have now the HTML version of the Finance with Python course. So in PDF, this is something like 150 pages, and it provides a gentle introduction to finance topics as well as related Python topics. On the left-hand side, you see that you can scroll down where you see the overview here. And this goes to chapter 7. This is the current state, which ends with the dynamic economy, where we cover here binomial option pricing and Black-Scholes Merton option pricing. But as promised, it starts very slow and very simple with the two-state economy. So here, for example, when financial assets are introduced, let me go to that point. You see that we are just working with simple vectors here, just 2 elements. So it's really simple in that sense. This is the basic purpose of this whole course. So to keep the examples as simple as possible, to nevertheless introduce all the fundamental financial notions, and at the same time to make use of fundamental Python-related concepts. Basically, throughout what you will see in this part is that NumPy plays the central role, because NumPy is the tool of choice when it gets to linear algebra operations and the basic finance that we cover there. It's mostly of linear algebra type problems, in the sense of that we work with vectors, with matrices, we solve representation problems, we talk about span and all these topics here in this regard. If you need a refresher in this regard, this is the starting point. In addition to the static material, you have the following resources: Finance with Python videos. So I can, for example, open here the video, or I can, what I'm now going to do, I can click here on Finance with Python on the first module. And what you see is now that I have more resources available. So more resources available in the sense that there is the video button once again. There is a link, for example, to a slide deck. The slide deck is provided here as well. And there are a couple of Jupyter Notebook files attached here as well. So if you say, well, this is interesting, let me start with this. I want to have a look at what is covered in Finance with Python. You might start with the first video here. And you see down here that it's 130 minutes. I can fast forward a little bit and see a couple of things that are covered there. Finance with Python, and I now do a quick run and you see kind of the live thing progressing. Of course, probably you would simply run it. So this is the video. Now I might say, oh well, Eve is kind of building a Jupyter Notebook here step by step. Where can I find that? This is also available. So you see here in the video, it's 03 Finance with Python Live. And in the module itself, you also find 03 Finance with Python Live. So I can double click on Finance with Python Live, 03, leading number. And now we are kind of at the core of the tools section. So that's the reason why I started here with the content, because from the content we kind of redirected, if you like, to the tools section. And you see that we have now opened the Jupyter Notebook that was built during the class, and you have it immediately available for execution there. So you can adjust it, you can work with it, you can just execute it step by step if you like. So you have the full access to all the resources. So to have a quick wrap up, you see here that we have the static content. This is, if you like, the electronic book. There's also PDF. I will show you the PDF. Then we have here the training with finance videos that accompany this course. Then you have the first module, which I've opened with all the resources. Then I have clicked on the video, where you see the video. And last but not least, the Jupyter Notebook that was built during the recorded session. If there are, let's say, other resources which were used during a live session, then you find them there as well. There might be a Python script, a wrapper, or other stuff that might have been used. You find this in the module as well. Similarly, maybe I close this first in order to not have too many things open. Now I've closed everything related to that. Python for algorithmic trading. This is now the core text for the algorithmic trading part. See, this is quite a bit. Also as an appendix about Python, NumPy, Matplotlib, and Pandas. And this is quite a bit. I mentioned it before. It's 450 plus pages as a PDF. So here it's simply a single page HTML, but you see this can be easily navigated here by automating trading strategy, going to capital management or whatnot. You see the formulas in between in text here, and typically also then followed by the code example. So this is kind of the style that I've tried to implement here throughout, that we have text, explaining, introducing problems, then providing the math, the formulae that are needed and so forth, and then having the code, the Python code, so that you always have kind of the three more or less together whenever this is possible and appropriate. Now, with regard to the topics covered there are a bunch of resources that you can rely on. So I would go first here to certificate program, which is where you see where we have quite a few videos provided here. So it starts with the original introduction and overview, then Python and Linux infrastructure environments, Docker containers, Python toolchain. For Windows users, I have a dedicated video here, Windows and SSH. So if you're a Windows user, you might start with that one. Then we have financial data science, a 1 or 2, vectorized backtesting, event-based, regression-based prediction, classification, real-time data handling, streaming visualization, Icon Wonder, interactive focus, Gemini, and automation. So here in principle, you see already that all the videos here are along the lines of this table of contents. In the video section, there are actually a few more topics covered, but the basic structure, the sequence is along the lines of Python for algorithmic trading. So what I said before holds true for the modules here as well. So if you say streaming visualization is what I'm interested in, or what is next for me, you click on it and you see then all the resources. And you see, for example, here there are 2 notebooks, there is a PDF file, there is also a data file provided, and then there are a couple of Python files and a algo sample config file, and all the resources that are used there are provided in this context. Video, files, double clicking on it will open it. So for example, you say, oh, well, what was kind of the, Eve used a couple of slides there. So, and you see, oh, well, there is kind of the slide deck that Eve used for the presentation. Everything readily available. Then we had recently our online summer bootcamp, and this was kind of a rather intense 2-week bootcamp where we covered all the topics, not in comparable depth to what you see here. So if you like, in this part where we have only 6 sessions, so to say, most of the topics from the Python for Algorithmic Trading material is covered there in a rather concise, high-level way. So there's an intro session, there is a session about the prediction parts using OLS, machine learning, TensorFlow. Then there is a streaming session. Then there is also a little bit about icon visualization, also on the trading platform, interactive brokers as a platform in combination with cryptocurrency trading at Gemini, and automation. So this is, if you like, the intense version, the summary version, the management, the executive summary. If you want to get a quicker run through, you could watch the 6 videos here. You can also use them as a recap. So if you have gone through the topics here, so covered the details first, you can then say, oh, well, I want to have a recap of all the topics covered. I go here to the more concise version and watch the 6 sessions that are here in the online summer bootcamp. This is optional. I have provided in the study plan kind of this as alternative auxiliary material. Then you have here more classes and programs. Not every single item might be open, depending on what you have booked with us. But financial data science is open to everybody. So this is the part which is based basically on the book. I must say that in some areas, the code might be a little bit outdated. Not due to the code that we have formally implemented, but for example, due to the issue that Yahoo has stopped providing the service that we use throughout and so forth. So a couple of changes outside of our influence have made the code in some areas either obsolete or needs to be updated in this regard. But nevertheless, there are special topics that I say, well, the math tools, for example, they might be interesting for what I'm doing. And I would say this part, for example, also stochastic parts, for example, these two, they are not influenced by what has been happening out there. Then performance Python, here you see one module, but there is also a performance Python talk that I mentioned once already, here in webinar talks and special topics. So here I will add certain things that are beyond the program or any of our classes, like the performance Python talk that I've given at the Quant Finance meetup in London on 18th September 2017. So this is up to date. This is rather recent, obviously. And you can, of course, have a look here as well. There's another webinar that we did. Free webinar, hashing, encryption, blockchain, Bitcoin. If you say, well, I'm interested in cryptocurrency trading, but maybe I would like to have a refresher with regard to the underlying technologies, you find it here. What I want to point you in any case is not only this part where we will post all the special things that might not fit into the other areas, but here is the introduction to the Quant platform. What I'm doing right now here, you find another video which provides you a quick run through for, like, let's say, of 15 or 17 minutes, showing you also the single elements of the Quant platform. Here I'm focusing more on the content side because this is so important for what we are up for. So by now you should have a good grasp of how to access the content and the additional resources. Typically we have kind of like the modules, the videos, and then the resources like slide decks, Jupyter notebooks, Python files, and so forth. And here in this context, I mentioned that there are PDF versions available. And basically, this is now the point where I want to open the file manager, because via the file manager, you see the structure here on the left-hand side is now replicated in the 2 columns. And on the right-hand side, I can basically implement now a couple of operations. Most of them are accessed via a right-click. So when I do a right-click, I can do delete, rename, creating copies, implementing basic Git operations. You can zip a folder, for example. You can download the file. You can send to. And what I want to illustrate, I hope that most things here are self-explanatory, but what I want to illustrate is based on a typical use case. People typically reach out to us that when I go, for example, to PyAlgo, here, there you find PyAlgo course PDF, and I can click on this. This is password protected for certain reasons. Everybody should have received the password. And when I type in the password, to see 458 pages. And now on the Quant platform, you have the PDF version of the PyAlgo trading material. So we can go through. It's the same content. Looks different, of course, completely different rendering and so forth. But it's the same content as the other one. Still kind of a, I hope at least, for me, it's a nice rendering based on ASCII Doctor, what we use for the documentation. But on the platform, I personally would prefer that one. But this is personal preference. I think, and this is the reason why we have added the PDF version in the first place, that most people, if they want to read the PDF, they want to read it on their iPad or on their notebook that they carry around with them on the airplane. And here in this folder where you find it, PyAlgo course, I can do a right click, then a download, and I can then download here to my download folder where there are obviously a bunch of older documents in there. And then you can easily save it, and in combination with the password, you can carry it around on your iPad or on your MacBook. The same holds true for the FinPy folder. There's also the FinPy course. And so and once you have opened this, it looks the same or similar at least. It provides you with the content, and you have full access, can download it as I've shown before, and with the password you can use it on any kind of device that you prefer. Yeah, there is a related question, fits very well into what we're covering. Yeah, you can download the files from each of the modules to your local folder via the same way. So for example, here, if you want to download this Jupyter Notebook, for example, works the same way. You can go here and download. You can also, for example, when I navigate back and say, for example, FinPy here and do send to a zip file, it creates me a FinPy zip, and then I can download this zip file. So that you don't need to do it for every single file if you have, let's say, 50 files in there. If for whatever reason somebody hasn't gotten the passwords, please reach out, but they are provided generally with the initial email. Once you are registered on the platform and you get your credentials, you're typically provided with the passwords as well. If you haven't, for certain reasons, we don't share them publicly or not even here in the closed area, please reach out and we provide you with the password so that you can make use of what we have here. Now you see that there is on the left-hand side also an important point, and I haven't explicitly not been doing it for myself so that I can highlight it. This is of course a current version now in the FinPy or in a FinPy folder that I've zipped here and that I might have downloaded. But as we go for the classes here for the course material, we update the material. So the next updates most probably will be for Python for algorithmic trading. But the last ones have been for finance with Python. And then you might see here a button update, And if you want to get access to the most recent version, you need to click it. Why do we do it? Because people might have changed the stuff that we have provided, and they want to keep their changes. So there's kind of a security check before that people are prompted to confirm that we are allowed to override everything in the respective folders. So here I don't want to do it. I want to keep it for illustration purposes that way. But if I wanted to have access in my folder, in my personal FinPy folder, I would need to update it. Probably with your accounts, when you have registered, you don't see it. But if you see just such an update button, click on it and you will be provided with the latest version. With regard to tools, what else do we have? When I go here on the task manager, you see that the Jupyter notebook that I've opened before is still running. So this is a typical thing that I'm in a certain folder, I'm running here a Jupyter notebook, then I navigate to someplace else, simply close the tab, and this is still running. So I might want to shut it down from here, or I say, well, leave it running because it's doing something. But here, at least in the task manager, as with the original Jupyter notebook, you get an overview of what is happening. So for example, when I open a new shell, a new terminal here, and go back to the task manager, we now see that there is also a terminal running. So for all terminals and all notebooks, we get kind of the overview here in the task manager and can shut them down from this location. So we can't miss the single things that might be running in the background without us noticing it. Then the last real tool that we haven't covered is the editor. I don't want to open an empty editor. I will look for a Python file that I can make use of. Now let me probe. Here are a couple of Python files. You see here in this chapter 04, there is one Jupyter notebook, but a couple of other files. So mean reversion vector backtester, for example. So when I double click on that one, we see that now the Python editor opens, and with nice syntax highlighting and so forth, we have full-fledged editing capabilities. Of course, for those of you who have worked with Jupyter Notebook, you see that we are just wrapping here the wonderful functionality from Jupyter Notebook within our Quant platform. We used to have our own editor, we used to have our own shell, and then the Jupyter team came up with their own terminal and their own editor, and then we replaced it by what they have been come up with, because we really like the job that they have been doing, and I think most of you will like this too as well. So here, traditional Python code editing on the platform. But this is not the only way of doing Python code editing. You have here a full-fledged, I increased the font a little bit, a full-fledged environment as well. So I can, for example, navigate to the same area here, and you see that I'm now in the same folder that I've used before, and I can do Vim editing of the other file here as well. So for those of you who are purists and like to work with Vim on the terminal, this is also possible. I think Nano and maybe the older one is also installed, so this is sometimes really, really handy. Just to show what we are up for here. Full-fledged server shell. And if you say, well, I'm also an expert with regard to file operations on the shell, all of the things that you can do here can, of course, be done also in the file manager, can, of course, be done here as well. So I can remove, I can rename, I can do zip operations and so forth. This is all possible. We have Git installed if you want to work with Git, for example. So I think we have kind of a proper basic set of tools that we have installed here that you have access to. Among others, what we also have, and this brings me already close to a little bit of an illustration, is that we have here, I can simply stay here, is that we have IPython installed, and with IPython I want to show you the little example later on. But before we do this, I think after this rather comprehensive walkthrough, basically the content area, the tools area, or maybe just now that I'm revisiting it, I see that I've forgotten to mention a very important topic here, namely the user forum, where you see that there are a couple of very active forum boards. The most active, I think, here is the Python for Algorithmic Trading one. When I open this, you see here, after my login, there have been a couple of things. We can basically reply by email, so this is what I mostly do. And you see here one topic which is really current, and frankly it is annoying for us because we have been relying on this data service now instead of Yahoo, and Google now changed the API and the data that they provide as well. And this is here, you see missing prices from Google, and there are others like other cryptocurrency platforms than Gemini, or logistic regression lags very large, or you see this is all related to topics that we cover. So I always say, please, if you have technical content related questions, or questions regard to the program itself, which are not related to your personal account or to your personal issues, please post the questions here in the forum. We get notified by email anyway, so it's in terms of timing and so forth, it's the same thing. But other people who are on the platform, who are in the program, benefit from such a way as well, because they might have the same question, might not be willing to put out the question on the board or to reach out, and then they say, well, thanks, I have found it. And there is also here ways of searching certain boards. So indeed, you might have a look first, might look through it. There's some very short threads. You see just one reply. There are longer threads, 8 replies. So just have a look and give it a try. If you have a question which is not a personal one, this is of course better handled by email. But if it's a technical one, program-related one, or whatnot, please use the user forum to use it. But this now closes the circle with regard to the tools here, so that for the moment I might close up these things. I'll let this one open. I can close the PDF ones and that one as well, and I will later come back here. So after the Quant platform, I wanted to show how straightforward it is to set up a Python environment. In this regard, you will already notice that it's not our primary goal to lock you in on the Quant platform. So many people reach out and say, well, is there kind of a lock-in? And if I work on the Quant platform, am I tied in to your environment and so forth? No, to the contrary. We rather want you to empower to set up your own Quant platform. So your, however you call it, XYZ or Algo Superpower Quant platform, this is what we want to empower you. You can also, as you have seen, you can simply create zip files. You can download everything. We don't work with any proprietary data formats or nothing. It's completely open. We try to live here the open idea as good as possible. In that sense, we want to empower you to set up your own environment. And your own environment, when I quickly go to DigitalOcean, to the website and go to pricing, you see here the standard droplets, which are the ones which completely suffice for what we are going to do. Usually I work, and my illustration will be with the cheapest one, just to show you that to set up your cloud-based infrastructure can be as cheap as $0.007 per hour. So $5 per month is the maximum that you pay for it. 0.007 per hour. So if you use it for, let's say, 10 hours, you end up with 7 cents here. Not that much, I guess. and kind of cheap, in particular in the development state where you say, well, I fire up such a cloud instance, I destroy it afterwards, and later on, if you want to deploy it, you still can migrate to larger ones where you say, well, I need the compute power, I need to have parallel processing or whatnot, but for the start, this is already okay. There are specialized droplets if you say, well, but my problem requires huge droplets. Here, for example, you see 132 dedicated CPUs, 48 gigs of 48 gigs of memory. Or you can have the high memory ones. Here you see even better, 32 CPUs and 224 gigabytes of memory. So to scale it up, it's kind of simple. Also, this is what we have been starting recently to come up with block storage. So you see the cheap ones. So these two are the ones we generally use, like that one where you say 1 gig of memory, 1 CPU has, for example, 30 gigs of SSD disk. This is not that much if you work with, for example, tick data. But you can attach such a block storage to your small droplet. So, for example, if you say I want to have, I don't know, 100 or 200 or 87 or whatnot more, you see that this is just kind of a fixed price that you pay per gigabyte. So here it's 10 cents per gigabyte per month that you pay. So it's easily scaled. You even can later on scale it up. I don't know whether scaling down works, but you can scale it. You can scale it up there in this. So something that we use because, well, we want to store lots of data, but we don't need a gazillion of cores, and this is one cheap way of going about it. But let me now simply fire up such a droplet. So this is I've logged in 2 hours ago or what to my DigitalOcean account. So this is of course something that you need to do, and before you create one, you should rather look it up in our documentation because we provide you with a discount code so that you get started with $10 positive balance. So 2 months for the smallest droplet if you use our code there. No strings attached, but a good starting balance already. And when I now go about and create such a droplet, you see create droplet. Ubuntu 6.04, kind of what we use. They want you to use that one. I go with the smallest one just for testing and development purposes. I might, Frankfurt is default because I'm here in Germany. Maybe I simply take the London one. And here I provide a SSH key. All this kind of in the how this all works and SSH keys and how to create one. You find all the information in the background in the course material, in the video recordings. So don't be afraid if this now goes a little bit fast. I call this AlgoCert sample, just to have a name. And now I create it. They promise, or part of their value proposition is to say that setting up a droplet takes 1 minute. From my experience, in 80% of the cases this works. Sometimes it takes a little bit longer, but a little bit longer, that means maybe 2 minutes. So here you see our other droplets. Some of them are running for years. Sometimes we have 10 or 12. Currently, it's just 4 that they are running. So in here you see now that there is the droplet already up. I think this was less than a minute. So their value proposition worked out fine. And I need to know now the IP address because this is kind of the unique identifier for my personal droplet. Now I can copy it by clicking here. And the next step, that I now need to do is I go on the shell because everything that now works needs to be done on the shell. So the I'm doing a copy first, a safe copy. Again, be assured that this is all explained. And now the next is that I log in to the cloud instance, you see I've just copied the IP address, and I'm going to copy this to root. So this is just a secure copy, which works via SSH, where I copy a local file which will install all the functionality for my droplet to the remote droplet. There's a security question. Once I've answered it, you see this is already copied. It's a very quick operation, and you might ask, what did he copy there? So, and what I copied is this little script, which is droplet install. And this is a bash script for droplet setup. So it first takes care of Ubuntu Linux related things. It then downloads Miniconda to have a Python installer. We install Python 3.6 here in this regard, and then we install a couple of useful libraries or regularly used libraries, pandas, 0.19, for certain reasons, for compatibility reasons, not the latest one. Pandas data reader, matplotlib, IPython Jupyter request. I have commented out a couple of libraries here because we might not need them there. So it's just an example. We won't want to work with it. And down here we set up the basic configuration for Jupyter Notebook. And the final thing should be that this script fires up Jupyter Notebook so that we can access our droplet from a distance via the browser. So details are not that important. Basically, the major parts, we take care of Ubuntu Linux, we install Python, we install Python libraries, and we fire up Jupyter Notebook, which will be password protected. So this is the basic functionality. In the materials, you find more sophisticated scripts which also add SSL encryption and a couple of other things, but this is just a simple little example. So now that I'm here, I can go and SSH to log in, remotely log in to the droplet. So I'm on my droplet now. When I have a look at my directory, at my root directory, you see that my file here is on the droplet in the location where I would have expected it because I've put it in the root directory. And the only thing that I now need to do is to say bash droplet, and I let it run. So this will now run for a little bit. Maybe you follow along for a few seconds. In the meantime, I can answer a question. There's a question with regard to the difference between the flagship algo trading videos and the ones on the certificate program. Some of them are pretty similar. They are from, let's say, a different round. Some of them in certificate program are updated, but you also find in the flagship algo trading, you find intro videos which are not available in the other ones. So we have kept this structure so far, but maybe we will move around the stuff a little bit. So I need to say okay here. We will move around stuff a little bit, but we have provided this or have given you access to it also as an additional source. So I don't see any point in not providing access to something that is there. So there's sometimes a little bit of a different focus for a certain lecture. There's a different approach used. There's a different example used, a different stock used, a different Python idiom focused on, and so forth. So this is kind of what I wanted to have that you have access to the resources that we have available. Where do you find the discount code for DigitalOcean? I think, let me quickly check in the slide section. I think I have, this is already in the, when I go back to the overview, Megatrends, DigitalOcean. No, there I don't have it. So this was a wrong location, but for sure you find it in the material here, Python for algorithmic trading. So this is a good point because in the background now it is all running. And here chapter 2 says setting up the Python environment and 0.25 using cloud instances. And here there is in the first paragraph, you see already the sign up page. And this is the one that you should use. So copy a link. I post it here in the chat so that everybody can see it. So DO discount link. So this is the link. Looks like the original page, but it has attached a discount code so that you have $10 starting balance. But again, in the material, it's 2.5 using cloud instances. Now you see it also in the chat. So this is downloading now a couple of libraries, so shouldn't take too long because it's a remote server. They have really fast internet connection and everything is typically pretty fast. In particular, what is I/O related and web access download related. And it should be in yes, exactly. I knew that we are close to the finish. And you see in the second but last line here, it says the Jupyter Notebook is running at all IP addresses and then 5 times 1 as the port. So I need again the IP address. I don't need that one anymore. No, this was the wrong link. I need the IP address. So I go and copy it from here. And now that I have the IP address, I just need to add the port under which Jupyter Notebook is running. And you see there's a password. It's not that relevant for you, but it's Jupyter if you want to replicate the example. So it's Jupyter. And after login, you see now that on my remote cloud instance, I'm now up and running. So my browser asks me whether to save. There's no point in saving it because I will destroy it afterwards. But I can now go about and, for example, on the cloud server, open here my test Jupyter Notebook, test NB, for example, and check, for example, import, or let me check with NumPy SNP, and then NP random standard normal 100 numbers, and you see this works. So it took a couple of minutes and we have our cloud instance up and running, similar to the Quant Platform. It's remote, it has Jupyter Notebook, it has beyond the Jupyter Notebook, it has also terminal access. So here it opens a terminal. I can now make use of the installed files. For example, I can check here with htop what the resources are, what processes are running. And indeed, you see here I have some 500 megabytes of RAM. I have 1 CPU. So it seems to be kind of what I've ordered from DigitalOcean. And I can also do my editing here. So I can open, for example, the install file that I've used. You see the first version I've shown you on my local machine, and here you see the version of the file on the droplet from DigitalOcean via Jupyter Notebook. So everything up and running, and it works. So really, really nice way of doing it, and not that involved, I guess. So to get proper password protected and with a little bit more effort also SSL protected infrastructure up and running. Really nice. I'm still amazed by what we do here. So getting back to the overview of the case studies and demos, I said a little bit of basic finance with Python. And this is just as a very little and very brief appetizer for what to expect in this regard. So on the Quant Platform, I said here the terminal is what I'm going to use. And on IPython, we can do this already, like, again, using NumPy. NumPy is what we will use throughout. And if you now say, well, let's assume we have a very simple market, the stock market, with a stock that has a stock price of S0 of 10, and the bond, which has a price today of 10 as well. Tomorrow, the future is uncertain. And in our simple world, this world is intensively discussed over many, many pages in the Finance with Python class. We assume first that there are only two states possible. So here we might say for the stock, there might be just two payoffs, like 20 and 5, which translates into that from 10, the stock might rise by 100% to 20, or it might fall by 50% to 5. And B, which is assumed to be a riskless bond, we might say, well, this pays, no matter what state materializes, 11 and 11. Maybe I put in here a dot to have float objects. So this is already a simple model for a financial market. We might now go and put the things together. So, for example, we have, let me quickly just redefine S0. Oh no, I think, yeah, let me redefine it to 10 zeros that we have float values. This is a special topic that is covered as well in terms of dynamic typing in the pandas universe. But we might then say, for example, that we have a market price vector today of S0 and B0. So M0 is 10, 10. This is our market price vector. Then the market payoff matrix, if we want to model this in the same fashion, is NP array. And we put in here S and B. And I'm going to transpose this so that you now see that the matrix is 20 and 5, 11, 11. So now we are already in the middle of the linear algebra world. We have a market payoff matrix and we have a market price vector. So vector, matrices, and all these things. Here we work with arrays. This is a one-dimensional array, a two-dimensional array, but mathematically we would maybe attach different names to it. And the basic problem that is covered in the Finance with Python class is the pricing of options. So if I have a call option, for example, or let me start with K, the strike price of the call option for the stock might be 15, so that we introduce a little bit more of symbology here. We might say, well, the future uncertain payoff of my call option is NP maximum S minus K and 0. So this is a vectorized operation, the first that we see here. Vectorized means I don't need to iterate over anything. So vectors and scalars can be easily combined. And when I now have a look, and I told it before, in the sense that all these calculations are so simple that you can easily do them in your head or with pen and paper. So it's not kind of like that you have huge matrices that you find in machine learning, like 5,000 times 5,000 or what. It's very low level. But the question here, and an important one in the whole quant finance space, is what is kind of the proper price for the option? So we know what the stock price is, we know what the bond price is, we know all payoffs, but the question now is, what is the proper price for you? And this is where linear algebra comes into play, where we say our regression, or let me call it already phi for the portfolio. This is what I typically use. NP linalg, there is this sub package linalg, which provides us with a bunch of linear algebra operations, and we can now solve the representation problem, or in finance we would say the replication problem of replicating the payoff of the option with the matrix of the traded assets. So when I look up phi, what I see here is that a third of the stock and minus 0.1515 and so forth of the bond obviously replicate the payoff of the option. So we can check this easily. Again, a little bit of linear algebra. NP dot M and rec. Not rec. This is what I use generally. So please excuse me for the confusion. Phi, rec in the general context, phi here in the portfolio context. When I take the dot product of the market payoff matrix and phi, I get, with a little bit of rounding, I get the result, 5 and 0. So obviously this is kind of nice. But now from arbitrage theory and quantitative finance, we know that if we have a replication portfolio which perfectly replicates such an option payoff, then the price of the option by arbitrage arguments must equal the price or the cost to set up the replication portfolio. Otherwise, arbitrage would be possible. So here we would say that we have C0, then is NP dot, the dot product of the market price vector and the portfolio vector. So C0 in this case now shows up as 1.81. For some of you, this might look really, really simplistic. Others have maybe never heard of option pricing theory, arbitrage pricing. I think for both, it's kind of worthwhile to go through the material in this part, because it's not only about the financial background. This might be an additional benefit to review the financial material, but it introduces some basic and very important Python idioms, NumPy concepts, linear algebra concepts, also introducing the first stochastic concepts for simulation and so forth. And you see it's just a couple of lines here, and we have solved the basic option replication problem. Well, I mean, Flax, Scholes, Merton came up with a theory in 1973, and later on, towards the end of the 19th, were awarded the Nobel Prize in economics. Unfortunately, Fisher-Black was already passed away at this point in time. But what we are covering here with simple Python and talking about just in terms of vectors and matrices and so forth, linear algebra, has been a hard problem up until the early 70s. And here we go. A couple of lines of code and we solve a major problem in finance, namely to derive an arbitrage-free price of a European call option. So that's already it in that part. And you see all possible, of course, on the Quant platform. I could have done this locally. I could have done this on my Droplet instance. So this is not really kind of the point here, just to illustrate how simple it is. So here, all these areas, I don't want to follow up. So what is all that is related to the Droplet, I'm going to close. This was just to show how straightforward and efficient it is to set up such a Droplet with a complete Python infrastructure. So here my test notebook, I'm going to close as well. And now we might move on to the other case studies, Icon and Plotly. This is a nice one as well, because it shows what you can do with professional data sources. I'm not going to spend that much time here on the details. This is just to give you a glance at what to expect in the respective sessions. I'd rather want to walk through kind of quickly and let you see what kind of charts and stuff is possible here in this regard. Before I dive into it, there's a follow-up question here. Whether it's necessary to use Ubuntu or not. Whenever we do something in the cloud, I think Ubuntu is the top priority operating system that you should strive for these days. I think it's the most popular one around the world for these and similar circumstances. I'm using Mac here. Mac is also in principle a Linux-based system, so this works kind of nicely. But I can assure you, if you work on Windows, many topics that we cover and approaches and things that we're going to do are not as straightforward on the Windows environment, at least with the basic Windows. Now there seems to be Bash and everything available on Windows as well. So this might be a good way to have kind of an emulation or a terminal version there as well. But I'd recommend using Ubuntu when you work with a cloud-based instance. Or I think Mac is always kind of a good compromise in terms of having a nice GUI, nice operating system, plus a Linux or mostly Linux-based infrastructure. So whenever I travel the world and I'm at conferences, I think that the Mac world, at least the portable computer programming world, is kind of dominated by Macs these days. But this is, like usual, a little bit of a philosophy issue, a little bit of a background issue, also a little bit of kind of the environment you're working in. If your employer says, well, this is the only thing that we use, then you hardly have a choice. But sometimes you have choices. CentOS, we don't have that much experience. I think it's pretty close still there, but we haven't tested it, CentOS. Others are available on DigitalOcean as well. So just give it a try. If you say you're an expert there and you wanna have that, so this should all kind of work. Then minimum spec hardware when working locally. I personally am using 2 MacBooks. I have a rather old, I think it's 4 years old, MacBook Air, 4 gigs of RAM, 256 gigs of SSD, and i3. Still, it's not that fast, but has 2 cores and 4 threads, so this works already. And most of the things I do are really implementable on the MacBook Air. So such a model, I think I don't recommend to buy something from 4 years ago. My point is to say it still works mostly on my MacBook. But some things when we work with TensorFlow and there's parallelism and stuff involved, then it can get really slow. Even if it works out and you can come up with the result, it might take a while. So on my desk, I use it as a desktop. I have a MacBook Pro with i7, 8 threads, 60 gigs of RAM, 512 SSD, and using a new big screen, 4K screen. So this is for back home where I work all day. I like to have it a little bit better. It's a 2016 version, and it's still, so I've never experienced any kind of bottleneck with this type of machine. But of course, there are already 27 versions out there. So this is maybe up to budget, up to taste, but with a regular current MacBook, no matter what, i5, whatnot, I think you should be really, really fine. The only thing is, if you want to make use of the newer displays like 4Ks and so forth, I would check that there is kind of a graphics card built into the MacBook, so that you don't run into any kind of resolution or frequency issues in this regard. Yeah, but these are good questions. I mean, we spend that much time in front of our machines, and I think a minimum level should be surpassed, but it doesn't have to be the latest and the greatest and the most cutting edge. Not from my experience, what we do. If you run into any bottlenecks, I'd rather go for like 4 hours and run the big machine and do my heavy calculations on the big machine. So then you pay for 4 hours and not for the latest and greatest, which is not any longer the latest and greatest 4 weeks later in that sense. Now getting back here to the icon story. Here there is something running in the back end, and once again, this is all subscription based. I cannot provide you access here. It's all subscription based. It's the API proxy, which is running locally, and via my Python wrapper, I connect to the proxy. So this is what will happen here. I have Plotly here imported locally as well. I'm connecting to the icon proxy. And the first step that I do here is I retrieve some end-of-day data. A typical use case is 2 years worth of end-of-day data just for Microsoft and just the close field. Very simple case. You might be able to replicate this, for example, let's say with Quandl as an open data source. I plot, and then a little bit of parameter tweaking, and you see that we get this as a nice interactive plot here, where we even have a best fit line plotted through it with the defining equation also provided. And the nice thing about Plotly compared to static plotting libraries like Matplotlib is that I can zoom in here, for example. So I can even further zoom in. I can zoom out and I can do much more here. I could embed this to a web page in interactive fashion. And here you see, for me, in my Jupyter notebook, I have all the interactivity that is so nice with the Hoover effects and so forth. Relative performance comparing two time series. So the same use case, but now with two names. Microsoft compared to SPX, to the Standard & Poor's 500 index. Same period. Now we have two columns in the pandas data frame. When we visualize the two series, you see there is a normalize method call, and then we do the iplot on the normalized data. All starts with 100. We also get here kind of the nice spread below, where we see, well, first Microsoft underperforms the SPX, and then it outperforms for the rest of the time the SPX. So pretty simple, just providing a few parameters. Then people always ask me, well, where can I get intraday data from, like minute data? Yeah, for example, from the professional data sources like Thomson Reuters, you get it here from Icon via the same mechanism. I'm providing now 4 different names, requesting just the close value, start date, end date, and now minute bars, interval set to minute. You can go down to the tick data level with Icon. So it takes a little while for names, minute data. When I have a look at the info, you see for every single name we have retrieved 391 data points. Looking up the tail end, now 4 columns: Microsoft, Amazon, Facebook, Apple. I can, of course, normalize that. Now this looks a little bit different to the typical end of day charts, but recall, we are talking about 1 day here and 1 minute bars. So over the course of this 1 day, these stocks, these tech stocks have behaved as we see here. So I can zoom in as before and zoom out, and you see 4 stocks, minute bars, just a single line of code, and we can get the data. We can, of course, do a couple of calculations, like calculating the returns, and then, for example, show the histograms of the log returns. So, of course, once you have the data in your Python environment, whatever you want to analyze and whatever is possible with Python, pandas, and all the nice tools you can do here. So I know that the question is always coming, how much is the subscription? I cannot really comment on that, and I wouldn't, because I can only get you in touch with the right people, because this is dependent on what exactly you want to subscribe to. I think it's also a little bit of a question of location, but even there I'm not sure. So you see, I cannot tell. Therefore, before I say something wrong here, I can get you in touch with the right people, also with those who are running the Python beta program there with the API. So I know these guys. Just reach out to me and I can forward your email. Maybe you write, let's say, some formal 3 lines, and I get you in touch with the people. Then they can initiate the process, like a trial, and also provide you with the proper pricing information in this regard. Now, I don't want to spend too much time here, but a little bit of an outlook what cufflinks, the little wrapper library, can do is I'm here retrieving data for Apple on a daily basis, and some new addition, some recent addition is the Quantfig. You see here Quantfig, and this is meant to be a really helpful object for technical analysis. So first thing that you see here is that open, high, low, close data is properly visualized. So we get candlestick data here visualized. Well, not candlestick data, we get the data open, high, low, close visualized as candlesticks. So this works kind of straightforward. Of course, when I zoom out again here, it's hard to see how the candles are, but when we zoom in, we see it a little bit better. Then we might want to add things like volume. You see here, add volume, simple call, do the plot, and suddenly we have the volume information as we would like to have it, namely as bar chart below what we have there. Then simple moving averages, 10 days, 30 days, 60 days, green, orange, blue. And another execution of this persistent object. And you see that we now have the 3 elements. And we can always, always zoom in and see this in more detail. I can also click on the legend here and get rid of my SMAs. So I can have them on and off if you like. Bollinger Bands, another statistic, so 20 periods, Bollinger standard deviations too, and the colors are provided. And we end up here with Bollinger Bands, maybe getting rid of the SMAs. You see it a little bit nicer, also with slight shading here. See the shading of the Bollinger Band and what is happening here with the candlestick charts. I can get in the SMAs once again. So all this is possible. Of course, in the other direction as well, I can get rid of the Bollinger Bands here. Last point is that we can add one more subplot, for example, the RSI, relative strength index. Now you see that we have an overlay like before. Then there's volume, and we've got an additional RSI. We see over and undersold regimes. Here everything's set like usual to 30 and 70. And I think this gives you kind of an idea how powerful not really Icon is in this regard. This works with other data sources as well. So cufflinks, the charting capabilities, Plotly, so all the visual elements that you see here, they are independent of Icon. But I'm using Icon data to show you the visualization of what cufflinks is about. So if you are into the technical analysis area, you should give it a try. And once again, you find more detailed resources, much more detailed resources, and many, many more examples in the respective training area and modules that cover this topic. Also, this new one, QF, I think you should have a look at the Online Summer Bootcamp. I think before it wasn't even available, but in the Online Summer Bootcamp where we cover Icon and Plotly, there you will see more detailed examples in this regard. This is not to say that this is the only way of doing it. So in terms of financial analysis, I have another example prepared here. Let me quickly go to that one. I have first shown you, let's say, the high end, but this doesn't mean that we require something like this. Here I'm working with just standard open source packages, also with open data. You see here web get data Google, which means from Google as a data source, Amazon. And you see we also get open high, low, close volume data. So this is to say that the cufflinks quantfig capabilities can be used with such a data set as well. Here plotting the data with standard means, which means with matplotlib, just provides us, you see there's no Hoover effect, there's nothing interactive, I cannot zoom in or not. Only thing that I can do, I can save this as an image because this is a bitmap and not a D3GS interactive graphic. So it's not a data-driven document actually. But nevertheless, all the statistical analysis, what we want to do, for example, adding SMAs 10 and 30 can be added, and we can add this to our plot here without any issues. We can also calculate log returns, of course, because this has nothing to do with the plotting capabilities. Visualize our log returns for the time series. For example, pick out the top 10 values here in terms of returns, or these are the top 10 worst days, and these are the top 10 best days over the period that we cover here. So all these analysis things, they are possible, and you don't need professional subscription of any kind to get started with all what we are going to cover. So this is what we always say, there are no additional costs lastly involved. But we have the data issue that I mentioned. The data issue that Yahoo has stopped the service. Google has recently kept the data to 1 year, obviously. So we haven't gotten to the details. Maybe there's some workaround there. But there are other data sources as well. And one that I mentioned is Quandl. Here I'm importing Quandl, but in order to access certain data sets from Quandl, what you need is a free subscription. So here I'm from a file, from a config parser file, I'm picking out my API key from Quandl. Otherwise, I couldn't get the data. So it's, let's say, semi-open data. You need to have a subscription, but the subscription is at least free. And with the subscription, which is free, you get an API key that you can use here to retrieve data for Apple. So I haven't provided a start nor an end date. And when I now look up what data we have gotten, you see that we have gotten 9,280 data points, which means from 12th of December 1980, it must have been the IPO date, to the 29th of September, last week, Friday, close. We get the data. And this is well more than we can get now, also in terms of detail, that we can get from other data sources. So when I visualize this, you see this is much, much more than this 1 year data set. And you see here that I'm even capping the data. I'm just visualizing the data later than beginning of 2000. So there are alternatives, and whenever you might run into any issues with regard to data in the materials, in the videos, in the Jupyter notebooks or whatnot, and you say, well, I cannot get the data that is shown there because the service doesn't work anymore, please use Quandl. Maybe you need to set up a free account and provide the API key for your request, but then you, at least at this point in time, you get still kind of a longer, more comprehensive data sets in terms of time span than from the other data sources. That's the reason why I wanted to show it to you. Different data sources provide different data sets. And this might be one that is well worth being used for what we are up for. Streaming data and visualization is a rather quick case study and example. So I think here I have it open. So I can show you, I have here, I have two files, yeah, tick plot and tick server. So for example, when I show you tick server as a file, you see this is a small file, 19 lines of code only, simple tick data server. I use setmq, two more standard libraries, and I set up my own tick data server. So this is just to have a data source to which we don't need to subscribe to. So just to have something up and running which provides us with a real-time continuous data stream. But you see, it's just 19 lines of code. So when I run this thing, Python tick server, you see this spits out Apple as a symbol and then some numbers. They are random. There is no law. This has nothing to do with the real stock price. They're just random numbers that we can digest, namely digest by another file, tick plot. This is a little bit longer, but we must keep in mind that we use Plotly to do a streaming visualization. So this whole thing has 38 lines of code. And in the materials, it's in the recordings and the materials, is explained in detail how to do what is done here. And you see it is a little bit more involved. Okay, oh, well, now we have gone through, sorry, this is due to screen. Now we are back. Sorry, this is just due to the screen and the split that I use with screen there. And what I was saying is that you find all the details and background information in the material as well as in different video recordings explained in every detail. So here when I start the tick plot script. It imports a few things, authorizes, and you see automatically a tab pops up and my data is plotted here. So this is already my streaming plot, also with Plotly, now native, not kind of with cufflinks. And from here, when I move this to here, you see that this is now digesting the data, timestamping it. This is the tick data server. Here is the data that is retrieved, and in real time it is sent to the Plotly server, which provides us with the streaming service, and we get this real-time stream. Of course, we here can also go and zoom in. We can have 3 streams where we want to visualize simple moving averages or whatnot. So this all works. And this is, when I was speaking before of connecting code, this is what I mean by connecting real-time code, actually. There's a question with regard to another API, TradingView API. I can straight out say, no, we haven't worked with it. So I cannot share any experience in this regard. So streaming data, we can summarize here, less than 40 lines of code, and we are able to retrieve, digest, to work with, and to visualize in real time streaming data. So I think it's not too bad. And this can be even simplified. We have written a couple of wrappers that you can benefit from, but of course, first we want to show how this works out natively. This can run. So the last case study that we have is Wanda Trading Platform. And this is also a quick one, just to whet your appetite in this regard. In the background, what I have is I have the trading application, which is for free. It's a desktop trading application. And this is used by typical, let's say, retail traders, day traders, however you want to call them, where I, for example, do a right click and I say market buy, and then as I buy 10 units with respective multiplier, not providing anything else, it's just a market order. I submit it, and you see immediately I'm in here, and I am long 10 units of this CFD instrument. Same holds true as before. All the details are explained in the resources that you find on the Quant platform. If I say, oh, well, I have lost €9 so far, that's too much, or my goal wasn't reached, I simply do a right click once again and submit a close order. And I'm out. So you see, for day trader type of people, this is kind of like really straightforward. So I have everything under control. Even here in real time, I get my candles updated in 5-second bars and so forth. Well, this is really, really convenient already. But what we want to do, we want to interact with such an account, let's say in technical terms, with a platform programmatically. And to this end, we use Python, of course we do. First, we do a few imports. Then the connection to the platform is as simple as this line of code. I have already read here instruments, and I'm showing you the first 5 instruments. So there are quite a bunch of instruments traded there. So you see it's, I don't know, 100 or whatnot instruments here. So this is our universe. This might change depending on your location and jurisdiction. And getting historical data now is as straightforward as with Icon, for example. And it even looks similar. So we have one that get history, and we get daily data for like 1 year. Ask prices, you see 357 entries there, and data tail. And for example, when we plot high and low, you get it, simply plot it. So here it's a little bit more than a year, obviously, that I was asking for. So pretty straightforward. And here with Wanda, because it's their own data, there is no data subscription per se. So even with the FX Trade Practice account, as they call it, you get full access to the full data history, down to 5 seconds and for, let's say, 15, 17 years back. So full data access even with the practice account, because there are no data licensing issues involved. It's their data. Real-time data. You see here with just a single method call, I can already retrieve real-time data. Frankly, I'm not doing anything with it but printing. This is the default here, but you see I've retrieved 10 data points here in real time. This is GMT time, so it's 2 hours before our Central European, still summertime now. Now you have seen me manually placing orders, 10 units buy, 10 units sell. And I can do it here by simply calling create order. And when I now go to the trading app, you see that there is a long position, 10. So via Python, I have placed an order for my account. Now I said, well, I want to sell it. I've got enough from it. So I sell it, and you see it has vanished. So in real time, we interact via Python, and I'd say simple Python. It's not that involved, really. We interact with the platform. When we speak of algorithmic trading, I'm now going to show you the first simple or even dumb algorithm. It's just a time-based algorithm, but at least it is an algorithm. It does automated trading. It iterates 3 times over the following 4 rows of code. It buys 10 units, then sleeps for 5 seconds, then sells the 10 units, waits another 5 seconds, and repeats the whole cycle. So I can now execute this, have a look at my trading app, and we'll see automated trading. Now the trade has vanished. Takes a few seconds, and the trade is reopened again. So we have automated trading. Once again, please do not repeat this. No investment advice, no any kind of recommendation. This is just a time-based, simple dump algorithm. Going in, going out, and after 3 loops, this whole thing is finished. Now you might say, oh, well, I have been trading. What is kind of my account information? You get account summary via a simple method call, where you see how much money is left in your account, for example. Or you can have a look. Let me look up the transactions, maybe 200, well, 465, maybe 460. I can get all the transaction details of my recent transactions here, and every detail. I can then parse it and work with it. I can, for example, let me do a few more here. Parsing, there's one convenience function built in, for example, which prints the transactions. So here you get the transaction IDs, where the transaction has taken place, and then you see the amount respectively. As simple as that. You see just a few lines of code, and everybody who has a little bit of an idea what he or she wants to do with algorithmic trading might have noticed that we in principle have covered all the necessary ingredients. So here from the beginning, we know what instruments we can trade. We get historical data, not only on a daily basis. This goes down to 1 minute or 5-second data, for example. So no issue with data here. We can plot it, then we get access to streaming data, we can place orders, we can do algorithms that automatically trade, and we get via the API full access to all the account and transaction information. So all the ingredients are there. Of course, you haven't seen yet, and this will be part of the respective classes or sessions, I'd rather say, where we cover where there are kind of case studies with more sophisticated algorithms implemented. But the basic ingredients I've been showing you here via this notebook. So bringing me to the end to case studies and demos. Benchmark case of random walks. So what are we against? For many years, economists, statisticians, and teachers of finance have been interested in developing and testing models of stock price behavior. One important model that has evolved from this research is the theory of random walks. This theory casts serious doubt on many other methods for describing and predicting stock price behavior. So, and in principle, this is what we are after. We want to describe and predict the behavior of certain financial quantities. So there are many methods that what is described here have considerable popularity outside the academic world, like technical analysis. So technical or chartist procedures might be indeed worthless, completely without value, as Eugene Farmer writes here, when the random walk hypothesis holds true. But what is the random walk hypothesis? What are we against? What is the benchmark for us? So market is efficient with respect to an information set as if it is impossible to make economic profits by trading on the basis of information set S. So this is a little bit more technical, and what this basically means is that you have seen that almost everybody who works with Wanda has access to the complete history of every financial instrument. And if the markets there are efficient, then there shouldn't be any value in analyzing the data, be it on a daily basis or a minute bar basis or 5 seconds or whatnot. So there shouldn't be if markets are efficient. So this is the basic idea. And so to say, we need to prove that there is some gold that we can find by digging maybe deeper or differently or using different tools. A little bit more technically, if a stock price follows a simple random walk, no drift, and normally distributed returns, then it rises and falls with the same probability, 50%, toss of a coin. So this is what kind of the benchmark then says. So in reality, we see completely different things. We see drift. We see that the returns are not normally distributed, and many more things. I've given complete lectures on this topic about non-normality. This is part, for example, of the computational finance class. But here we just stick to a simple case, even here without without going into too much detail and stating it in a not that rigorous manner, so to say. But what is important for us is, in such a case, the best predictor of tomorrow's stock price, in a least square sense, is today's stock price. So this is something that we can operationalize, or that we can put into practice. And I want to show you a quick example. That all the examples are not too long, although we are already quite into our intro and overview. And in my random walk example here, the first thing that I do is I do a random walk simulation just to show how this might look like. So we have a starting value of 100. We assume a certain volatility and a little bit of randomness. Yeah, there's a question how long we're going to go. We're a little bit over time, but I think I will try to go not too much over time, but a little bit more is left. I hope that we don't run into any issues, but everything is recorded, so everything can be watched later in certain cases, but I think we should go through the important topics here. So we have still a little bit left, so bear with me, and we'll walk through the remaining parts now. Doing a little bit of a simulation down here, and here the calculations, the details are not that important. What I want to show you are kind of how this might look like visually. So this is now a random walk. You see this goes up and down, and every single path here goes up and down. And what I want to do is to implement a regression-based prediction. What does it mean to have a regression-based prediction? I take out one single path, and I say, for example, I work with the last 5 legs of the path. So I say, for example, I have 5 observations, and I try now to predict the 6th one. I have another 4 or 5, and I try to predict the 7th one, and so forth. So speaking about it is not that illuminating, but here you see the data structure, where we have leg 1, where you see the original path is simply pushed by 1 data point. Leg 2 is pushed by 2, and we push it by 3, by 4, by 5. So on this level, now we have the first complete row. Path, this is the original value, and these are the last 5 observations. So there are the 5, and now you have them in a row. This is the basic idea. And what we try to do is to take the last 5 observations to predict the current one. Also for this row, to take here the last 5, now of course 5 others, to predict that one, and so forth. So we always take the last 5 observations. And this translates into rather concise code here. We do a least squares regression. And we see here the regression parameters. And what we see here now is the path, which is red, and the blue one, which is the predicted value. And what you basically see is that the predicted value is more or less the value from before. So remember what I've pointed out here. The best predictor of tomorrow's stock price in a least square sense is today's stock price. And visually, we now rediscover this insight. The best predictor of tomorrow's stock price is today. So we simply take today's stock price and take it as the predictor for tomorrow. And here you see a couple of variations. So when I redo this, because this has some random elements, when I redo the simulation, we might see a different picture, but the same basic insight, so to say. Now a completely different part of the path, but the same thing. Red is more or less what we take as the predictor for tomorrow. So blue is more or less just the moved red line. And here you see the mass is almost completely, 115% in our case, on the last data point. The others have different weights here in this case. Simple example. But how does this look? And this is now the important test. How does this look when we go about the real world data, like Apple data? So when we visualize, this is Apple stock price data. Well, this is not something simulated, nothing that Python random number generator has come up with. The analysis is exactly the same, so details don't matter. All the details, like usual, are explained in the respective parts of the program. It looks structural-wise the same. You see it here, this triangle, 5 legs. And when we do the regression, you see here even more pronounced the effect that the last point has a weight, a mass of 100%. So what I said, that the best predictor in a least square sense for tomorrow's price is today's price, we see here almost perfectly reflected in our data. So when I do the plotting, here you see that the prediction values, which are the blue line, are more or less kind of a shift by 1 day of the red line. So all the peaks, all the lows, you can rediscover them here in the prediction. So I wouldn't say that this is kind of proof. So here you see it for the complete time series where you don't see that much. This is not really proof, but this is kind of a very simple verification or support, let's say, for the hypothesis that stock prices follow a random walk. But nobody says that our only analysis mechanism shall be some kind of least squares regression method. So we have many, many other methods available. So in that sense, the explanatory power here in this context might not be given, but nobody says that it is given in another context. Here this is just related, and the slide says it, to a least squares regression analysis. Hopefully there is more to it. So we now come to the final considerations of today with regard to the overall area we are working in. So technological singularity might be something you have heard of. There is this mainstream show which is called Person of Interest, which has as a background singularity. There are books, popular ones, Superintelligence, another one, Singularity Rise, and there are many, many other books. So I can only recommend that you pick up one. I think the Nick Bostrom one is a good starting point. A little bit involved, but it's kind of comprehensive, super intelligence. You even find it at many airports these days, so it's mainstream. And by technological singularity, it is meant that vast increases in biological and machine intelligences will create what's being called the singularity, a threshold of time at which AIs that are at least as smart as humans and or augmented human intelligence radically remake civilization. People also speak of superhuman intelligence and then exponential growth in intelligence. But first, the first goal would be to have general human intelligence. And we are still far from this point. Some people say, well, maybe from 2045 on, we will have this. But there are indeed some things that will spur kind of, or will accelerate what is going on there. So one is kind of what I talked about already. It's the development of specific hardware. This is one thing in combination with the specific software. So this will, of course, increase what is going on there, maybe even leading to an exponential growth. But nobody knows how fast this will go in the end. But we will really benefit from all this because in the end, we have the humans that we have always as a role model and human intelligence. The question is, what is it after all? People say, well, humans are just kind of algorithms that we need to emulate. And in that sense, the approach taken sometimes, it's just to come up with the algorithm that does the same thing that humans are doing. Another approach, which is, let's say, a competing one or alternative one at least, is to do a full emulation. So when you think of old hardware, C64, you have a Raspberry Pi. A Raspberry Pi can completely emulate the old hardware. So people are also working on simulating a human brain to reach human level AI. This is a really, really hard problem. So people are far away here, but they are at least on their way. When we think of other areas where this has taken place, we have a very good example where we have seen this. When we go to chess singularity as a threshold of time for which on chess programs play better chess than any human being. This is already years ago. So this has happened. This is something that is already in the history books. Namely here, very nice book. I can only recommend it, Deep Thinking, Garry Kasparov, is that in 85, he scored a perfect 32-0 against computers simultaneously. Just a few years later, 12 years later, he lost against Deep Blue. And then 2017, we have the case that any free chess application on an iPhone, on another phone, is mostly better than any human grandmaster. This is what we would then call something like a chess singularity, because the machines are much, much better at this. Did the human race resign and stop playing chess? Probably not. So we have here the insights from Garry Kasparov, which I share. It's kind of what we need to work on is the ability to modify and make our own digital tools. So we need to work with the machines. And this is all what our program is about, to empower you to be able to modify and make your own digital tools. I couldn't have better formulated it, what our program is about. So to be able to explore new frontiers and to apply the new stuff from machine learning, deep learning to the areas we are interested in. Financial singularity, very interesting. People talk about it since quite a while. Probably a little bit earlier, if at all, before the technological singularity, basically the day from which on intelligent machines rather than human agents will have taken over all investment and trading. But this is also another nice book. There is much to do. So today it's still kind of in its infancy, what AI can do or is currently doing for financial trading. But I think many, many people, big institutions with big budgets are working on making this happen. We do our best to empower you, that you will be able to make best use of what is going on there as well. Some companies, and I want to highlight here one, flow traders, not that well known from my point of view, by using such algorithms was able to book 34 months in a row without a single loss month. But not only 34 months in a row, but here you see not a single trading day without a loss. And this is kind of what I said, well, this is a goal to have a money-making machine on a large scale, which doesn't lose a single dime on a single trading day over such a long period of time. Nobody guarantees that the next 3 months will be the same, but at least what they write is the algorithms make at least to a large extent sure that the probability is rather small in this regard. The conclusion is that man and machine might be the way to go, and one of the biggest proponents in this regard is Peter Thiel, well known from founding PayPal, being an investor to Facebook, having written 0 to 1, and complementarity might be the way to go to make the best use, because algorithms are cool, Deep Blue is cool, but what computers can do in helping humans to achieve and to solve harder problems, this is what is kind of fascinating. And we are after all this with what we are here up in the program. Now coming to the program and how this is basically structured. First element is in terms of style. Here are just a little bit for kind of inspiration. 4 different areas. The first is a quote from Yamamoto Musashi from a couple of 100 years ago, which is about the tool set. So we focus on tools, not only on programming. So also the tools that you will be exposed to are very important from our point of view. Then we have the code side of things. So of course we will program. We will write programs, we will write interactive code, but as it's pointed out here by Martin Fowler, is that we want to write code that humans can understand, not the most sophisticated stuff in terms of, most complex and most advanced. If it does the trick and if it's robust, then I think this is the good code for us. And in our Python ecosystem, what we should always take care of, and this is another quote that is really valuable in this context, is that we should design our code around the data rather than the other way around. And Python in combination with pandas providing us with a data frame object allows us to write completely different code than pure Python would allow us to write in our context. So pandas data frame will drive many, many, many things, almost all things that we do whenever it is related to data. And it will drive the code that we write around this data. So this statement couldn't be more true than we had. And once we have all this captured, like the tools, the code itself, the idioms, and the data structures we work with, then the algorithms are the ones, and this is the last quote here, that we will take care of. So these are the 4 guiding principles in this regard. Many what you will see, many topics, many implementations will be interactive. So there's lots of interactive coding where you can, even if you like, follow along. You open up, you fire up your Jupyter Notebook, and you simply code along. Not only in Jupyter Notebook, but also some examples where there is some live coding in the editor where we write one program after the other. And I can only recommend that you try at least to code along. If you watch a video, for example, you can then stop for a while, you can pause, you can check what's going on. But you should do it, because I think this is kind of a valuable experience, similar to a boot camp where somebody is kind of showing something in, and you try hard to follow along in this regard. And it's all about skill-based training. This is what I want to emphasize. It's not about any kind of theory. We don't cover object-oriented programming, for example, in theory. It's just that you go out and do it yourself. You remember I've used the term a couple of times, do it yourself. So go out, do it, follow along, implement it on your own, come up with your own topics and try to solve them. Because if you solve my problems or the problems of somebody else is one thing, but I'm pretty sure that you have much more fun when you solve your own problems. And this involves here to define your specific goals, to go step by step, for example, with regard to the one-day live trading competition, that you get feedback. And we have kind of this nice situation that the financial markets give us feedback. You don't need kind of like, if you want to play tennis, you need kind of a partner. Here, you can program, you can do something, and the markets provide you feedback. Also, the Python interpreter provides you feedback, and also we provide you, of course, with feedback. Go a little bit out of the comfort zone. I want to highlight this one because many people say, well, I've always used this and that tool. Why are you using that one? Can't I go along this? There are some reasons why we use the tools that we use there. So please be open here, go a little bit also out of your comfort zone with regard to the tools and the environment. And I think you will learn a couple of nice things. And also, it should allow you to maintain your motivation. I know that most people are working full time. So if you have the feeling that you cannot implement the study plan, which I will show next, please don't be worried too much. Don't push too hard on your own so that you lose motivation. We even had cases where people said, well, if there were kind of special issues over the last period, can I be included in the next round? And we always do this. So people say, well, personal issues or whatnot, I couldn't follow along, or I changed my job or whatnot. We are always flexible and try to keep you in the loop and to give you also there the option and the possibilities to close up the program. The study plan itself, you find everybody of you has received the link to the study plan. This is now the final part, the very final point here. Everybody has received the link to the study plan. I've provided it with the invitation to today's session. You see here the link. I can provide it once again if you don't have it readily available. So this might be updated as we go, in particular with regard to the sessions. I've now posted the link in the chat as well. But I have snapshots here, screenshots, and I will explain, or here you have hopefully an explanation that answers all the questions, but I will go here to the overview. And originally, we have thought of the complete program being 12 weeks long. But this proved to be too ambitious. So I can't remember even a single person who was able to finish it over this period of time. So we have now stretched it a little bit to a 16-week program, which might be a little bit more realistic, in particular, given the point that we have added resources as we went. So we're now still going to add resources. But basically, when you ask me what is kind of the minimum that I should cover over the week, the minimum should be the stuff that is provided here in certificate program. So you see here the name of the videos, so Finance with Python 1 and 2 you should start with, and accordingly there is the reading material provided here. So Finance with Python chapters 1 to 3 and Python for algo trading chapter 1. If you want to review the stuff from a different angle, given another viewpoint maybe, you can also start with session 1 here. But this is just optional if you like. There's also a longer session, Python programming from scratch, if you are more interested in Python control structures, Python idioms, basic Python data types, but this is another 3 hours. So this would be already kind of challenging from my point of view. Apart from the fact when you say, well, I'm on holiday currently and I have 2 weeks of free time, feel free to do how much you can do. But at least the videos that you find here in the first column should be studied. This is kind of an alternative, more concise overview of the topics. There are kind of the videos that we would recommend from the flagship algo trading class. And some people, from my experience, are kind of from the start right into the Python infrastructure topic. So I have added here recommendations as well. If you say, well, this is something I want to take care of later on, you might push the Python infrastructure stuff to later points in time. They say, well, first let me master the basics there, and then I will take care of what infrastructure is needed when I want to go on my own. I'd rather maybe do it here in the context of automation when I want to set up my stuff in the cloud and want to have it up and running. So this is also an option. But I have distributed it here where I think, well, every other week, one more of these topics might be worthwhile. And throughout, you see that there are the chapters. And I said the basic sequence of the program is kind of going along the lines of the material. First, in parallel, finance with Python and a little bit of Python for algorithmic trading. And then you always find the chapters from Python for algo trading, here chapter 3. And what is also kind of helpful is the rather lengthy appendix of Python for algo trading, which is in and of itself an introduction in working with financial data. There's a recap and review of NumPy in there, a little bit of plotting. So yeah, rather concise and brief overview. For the beginning, beyond the introduction and overview session today, I have planned here for self-study week because I will be traveling throughout. So there is lots of material for you to get started. We are always available, mostly and best via the user forum. For other questions, I pointed out also by email, of course. So that from this week on, we will do more live sessions, which will then be announced. And you will hopefully have by then already the basis with regard to the basic finance with Python topics, with regard to the intro NumPy topics that you have seen, how, for example, pandas works in principle and so forth, so that we can then go and dive into certain topics a little bit deeper. And once again, it's not even exhaustive in terms of the resources that you find on the Quant platform. If you have specific questions, of course, you can reach out. Again, this will be something for the certificate program board on in the user forum. You say, well, for this topic, where do I find further resources, for example, or do you have a recommendation for an additional book, for example? It's a question regularly asked. But basically, for the next 2 weeks, you should get started with the finance with Python. And I'm pretty sure that not everybody will get through the complete material. It's 160 pages. At the same time, it's finance topics with Python, data, and so forth. If you get through this seamlessly, wonderful. But I think there you will gain a good basis for everything afterwards: financial data science, backtesting, and so forth. So this is what I wanted to point out, but again, few more hints and explanations, and also some points with regard to what you find on the Quant platform are here on the first page of the example study plan. Everybody should have access. You have access to the slides anyways. I have shared the link. You have access to the study plan. If some questions are open in this regard, I know that this is an important topic, you should reach out to us. So over the 12 weeks, we plan for kind of the learning phase, and then we will have a live training competition in week 13. Maybe if this is just kind of the year beginning, we might move this for 1 week due to market closings and bank holidays. And then there are kind of 3 weeks planned for the final project. But once again, we haven't had a single student so far who has finished it in 3 weeks. Most people have more ambitious projects and take a little bit more time to finish the final project, which is also created. And in that sense, people want to make sure that they can come up with something decent in this regard. This bringing me to the end of today's session. We have been a little bit over time, but I think it was worth the while because we have covered a few important issues for you also to review. You have the materials from today's session, like the Jupyter notebooks that you have seen, the other files that I have used. You have them on the Quant platform in the respective module. If there are no further questions at this point in time, I say happy Python coding and also algorithmic trading. I wish you all the best and have fun with your studies, and see you soon for the next session in our certificate program in Python for algorithmic trading. Bye-bye. Take care.